Hi, everyone. My name is Liz Oblicas, and I'm a marketing manager here at Repligen. Thank you so much for joining episode 4 of Repligen's 2022 webinar series. In the previous episodes, we covered analytics, for example, specifically the first and only variable path linked analysis technology, the Flow VPX. In the other two webinars, we talked about resins. First, about custom affinity resin development, which in our case is based on an unparalleled ligand library diversity, which allows us to get it right the first time. And in the latest webinar, we also talked about resins, but this time off-the-shelf AAV sodium hydroxide stable affinity resins, which so far are available for AAV2, 8, and 9. Today, we will continue in the theme of chromatography and be taking a deep dive into Repligen's single-use chromatography systems technology. You probably noticed in the last few years the growing complexity of newer modalities. The thing is that systems technology hasn't necessarily kept up with that. And that is exactly what the team behind these systems set out to address. Bringing high recovery, maintaining bioactivity, and lowering the risk of deviations for even the most complex modern modalities. Now, presenting to us on that today is Julie Grace, the Senior Director of Global Field Application Scientists here at Repligen. Now, before I hand it over to Julie, I just want to go over a few usual housekeeping items. First, so that you're aware that this webinar is being recorded. 2, there's a live Q&A to the right side of your screen, which is going throughout the presentation, and you can start submitting questions if you want to as soon as it starts. There's also an upvoting feature, so if you particularly like a question or you're really interested in it, then upvote it so we know what to answer later, what to answer first. And finally, check out the live polls. There's one already live right now, and there'll be another one before we wrap up this webinar. So do take a look at that. Now, that's enough for me, and let's hand it over to Julie to take us away.
Well, thank you very much, Lise, for the wonderful introduction. And hello, everybody. My name is Julie Grace. I'm the Senior Director for the Global Field Application Sciences team here at Repligen. And I'm really excited today to talk to you about the Repligen chromatography systems. So if you're not familiar with Repligen, there's a few key points here. But if you take anything home from this message, is that we were voted one of the 100 fastest growing companies in the world. And that was something I was really proud of when I joined this team. We've had 13 acquisitions, 10 major innovations and technologies, 18 global manufacturing locations, 2 major warehouses, and 5 additional office locations across Asia Pacific. So there's a lot going on at Repligen. You can see here in this next slide that the Repligen engineers solutions for all upstream and downstream manufacturing. We're focused heavily on process intensification and upstream, and we also want to make sure we can provide you with the downstream technologies that you'll need to process all that additional productivity that we're going to gain for you. So today we're going to focus on single-use chromatography systems from Repligen, and I will show you how to solve the yield, the shear, and the separation challenges of traditional systems through expert engineering and technological innovation from both the hardware and the flow path. But if you have any interest in any of our other technologies, please don't hesitate to reach out to your local Repligen rep, and we'll make sure we get you the support that you need. So today we're going to talk about the new Repligen chromatography systems, and I know by the end of this presentation, you're going to be just as excited to try it as I was when I first heard about it. For the Repligen chromatography system, every detail has been analyzed, and it's also been redesigned if necessary to maximize process efficiency for the needs of both the new modalities and traditional mAbs and recombinant proteins. So for existing chromatography systems that you're probably using today, you know there's dozens of built-in challenges all along the flow path, and especially for new modalities such as AAV or Lenti, we have to deal with issues such as low recovery, growing manufacturing costs, and faster go-to-market timelines. And for these new modalities, we really need modern technology designed specifically to address those needs. So to maximize process efficiency for even these most complex viral vectors, it really requires a step change improvement in technology. And over the next few slides, I'm going to talk about this. We're going to talk about increased recovery, protecting your bioactivity, and reducing the overall risks of deviations. So next you're going to see that this didn't happen overnight, of course. There were decades of components and system evolution that led to the chromatography skid that we're going to talk about today. The team behind these systems has been in downstream bioprocessing since the very beginning. Back when I had really big hair, lots of hairspray, and I was blowing up my speakers to some hair bands and rock ballads, way back in the 80s, we were there. And from then on, over time, the team here made step change improvements. So there are three key elements of process efficiency, and the first of which is recovery. With maximizing recovery really comes down to protecting your gradient integrity, both going into the column and then also maintaining peak resolution from the column exit to the collection vessel. The biggest challenge to both gradient accuracy and peak resolution is really the turbulence and the dilution, and we're going to cover these challenges and our solutions here at Repligen in the coming slides. So here you can see that separation requires control both before and after the column. Creating a gradient is really not hard, but it's maintaining that gradient that's the challenge. And that gradient integrity must be maintained from the mixing valve to the column, but we also must protect the peak resolution coming off of the column so you're able to collect the maximum product from these process. So both before and after the column, you have potential dilution, potential turbulence, and increased time that also leads to increased potential diffusion. So all of these factors will erode resolution, but we've developed multiple technology solutions in order to solve these potential issues. So the first of which is the bubble trap. We've had a unique and innovative solution to replace the bubble trap by a filter and level sensor-based alternative minimum dilution solution. The conventional bubble traps, as you know, can contain up to 500 mils of additional buffer volume that can significantly erode your gradient integrity through dilution. So the gradient that you set at the mixing valve travels to the bubble trap and then is instantly and unpredictably diluted, which erodes precision and reproducibility. So as an alternative, Repligen utilizes the filter level and sensor assembly that drastically reduces holdup and creates minimal dilution. This means that the gradient you set at the mixing valve can also be the gradient delivered to the column. And I'm going to talk about this a little bit more in a later slide when I show you a video, but some of the benefits include better separation and repeatability from run to run. So another way to improve recovery is the removal of dead legs in the single-use flow path. The Repligen valve block technology virtually eliminates the dead legs caused by hose barbs that you're using in your traditional flow path. The traditional systems use individual valves that are spaced far apart due to the use of these hose barbs, and the pinch point of the valve must be placed far away from the main line. This creates significant dead legs and also increases the chances of leaks and failures. So in this next slide, you can see a comparison of the Repligen flow path at the top to the traditional old style flow path at the volume. The gradient visualized in the traditional valve design, the bottom with dead legs, causes mixing at the gradient as it passes over these dead legs. So how do we solve this here at Repligen? By adding injection molding and some new hardware to the overmold, we see that the fluid dynamics at the flow path junctions have been completely transformed. The valve blocks bring the pinch points right to the main line, it shortens the flow path, and it virtually eliminates the dead legs. With no dead legs, there's no turbulence, there's no gradient and resolution erosion, and no crevices for cross-contamination. So the Repligen flow path that you see here at the top shows an intact, controlled, and consistent gradient with minimal or no dead legs to disrupt the flow dynamics. And it's the absence of these dead legs from the traditional flow path that maintains that gradient as it flows through the valve block. So next we're going to see a little video. Animation shows a transition from a traditional flow path with wide spacing and dead legs caused by hose barbs to a shorter spacing and no or minimal dead legs. You're going to start with the tubing design, which shows a traditional valve setup. The silver bands here representing the zip ties or possibly Oettinger clamps, and then the discs are the valves, and the hose barbs can be seen through the tubing. The magic happens when we remove those pesky hose barbs. With overmolds and injection molding, we simply don't need them. By removing the hose barbs, we bring the pieces closer together, we shorten and simplify the pull path, and we put the pieces back together and add the new pinch valves, and now you have minimal dead legs. And as you can see in this next slide, we're showing a close-up version of what we just discussed in our overmolded connections. So in order to promote laminar flow and reduce this turbulence, we have both reduced the number of connection points and then also replaced those pesky hose barbs with overmolded connections throughout the flow path. The connections are seamless and hose barb free. They have a constant inner diameter. They allow for unobstructed flow with no turbulence, improved gradient integrity, and they maintain that peak resolution between the column and the collection vessel. So as we've discussed in the previous slides, the Repligen valve block technology and overmolded connections protects the gradient resolution from the mixing valve to the column, but they also help protect the peak resolution as it travels from the column to collection vessel. Separation happens at the column and is optimal at the point when it leaves the column. So those of you that are used to working at small scale or PD scale might ask, how are we going to have dilution post column? So what happens in larger systems is when the first sample comes off the column, it elutes into the buffer. And the longer it stays in the tube, the more diffusion might happen. The turbulence also occurs when the flow path changes geometry from the outlet of the column and into the flow path. And at Repligen, we've re-engineered this so that the flow path has less diffusion, has virtually no turbulence-inducing dead legs, and is significantly shorter due to the valve blocks that we've already discussed. We've seen a 4-time reduction in dead volume, which also equals less dilution. So as I mentioned, there's 3 key elements of process efficiency, and the second we're going to talk about today is the protection of your bioactivity. So maximizing recovery is only successful if that recovered product maintains bioactivity, because of course, nobody wants to achieve high recovery of an inactivated biomolecule. So when manufacturing more fragile products such as lentivirus-based therapies, shear really is one of the biggest threats to product integrity. We have a lot of unique features that we've already discussed and can also reduce turbulence and shear and consequently maintain bioactivity of your sample. We use low shear diaphragm pumps, and we allow for increased pressure and low pulsation. Next to the pump, there's dozens of hose barb connections of traditional flow path that can be the greatest contributor to your shear. In addition to this, the benefits of the overmolding discussed previously, we've reduced the number of connection points, and as we discussed, we've reduced those hose barbs, which gives you the benefit of less turbulence, lower shear, and better maintenance of your bioactivity. This next slide shows in greater detail how the overmolded connections can really replace traditional hose barbs and create that low turbulence connections that also don't leak. The overmolded connections replace the hose barb, promote laminar flow, and reduce turbulence. The third and final key element of process efficiency is the reduction in deviations. And we really have paid attention to this because we love our operators and we want to make their job easier. So reducing the overall risk of deviations through the improved design and real strong focus on user experience with the operators in mind, we want to make sure that they're happy and everything is easier. So through this diligent focus on user experience, we've reduced the risk of deviations through time reduction and fewer operator areas through ease of use. And you'll see over the next few slides, the overall user experience surrounding the batch changes is going to be discussed, and you're going to see how it's safer, how it's easier, and more importantly, how it's faster. So here you can see with single-use systems, batch changes in the design of the flow path itself can cause challenges and ultimately lead to deviations. So at Repligen, we've designed a simpler, better designed user experience that not only saves time, but more importantly, will lead to fewer operator errors. So comparing that Repligen to the traditional flow path, you see that we have 2 steps, the autoclave step and the calibration steps, that are completely removed from the workflow. It only requires 1 operator instead of 2, and it installs in minutes and not hours. So this is where we see operational simplicity that improves execution metrics and reduces the potential failures. The user experience around batch change on a traditional system is typically too long and complex. It wastes valuable time and resources, and most likely requires a second pair of hands, as we've mentioned. In this next slide, you'll see in a little more detail the Repligen solution. So thanks to key changes in the system design, the batch change user experience is faster and easier, with less room for human error and required fewer setup steps. The flow path arrives in 4 pre-assembled gamma irradiated subsections. All single-use components have already been assembled into the flow path. It's intuitive, there's no tools, and virtually no mistakes. The user also doesn't need to calibrate, and as we've mentioned, all the sensors in the system come pre-calibrated. Once the flow path is on the system, just connect the 3 aseptic connections, and you're ready to rock. The flow path remains closed from receipt to running, which in addition to reducing operator errors, really greatly reduces the contamination risk. So it's popcorn time again. We're going to show you another video, and we're going to show a flow path installation on a Repligen chromatography system, so you'll see how easy and mistake-free it is. In this example, we see a 1/4-inch system. In the video, the first thing you're going to see is the flow meter. It's that silver cube with a small display. No need to worry about the error because it's a demo video. These are installed first, and the flow meter is placed inside the stainless steel exoskeleton to guide the installation and protect flow path integrity. The block opens and closes simply with locking knobs and no tools necessary. Next, we see the valve block. You have organization junctions of tubing and multiple valves to control the flow. The user closes the block around the tubing, securing it, and again, no tools required. Next, we see the filter-based bubble trap. The level sensor is installed, and then the sensor detects liquid in the bubble trap filter. It controls a valve to the right that acts as a vent to release any unwanted air, and that will protect your column. I also want to take note to the tubing. Anything not in an exoskeleton is braided tubing, of course, that's stronger and withstands higher pressures. But the exoskeleton that holds the non-braided tubing inside the valve blocks allows for the tubing to operate at higher pressures with non-braided tubing, which allows us to use cheaper tubing that's easier to install, and of course, it's cheaper for your manifold. At the end of the video, you'll see 2 more valve blocks, and once again, no tools required. So now that you understand some of the key innovative features that have gone into our Repligen skids, we also want to make sure that these core technologies scale from 1/4-inch ID all the way up to 1-inch ID. And the only difference you're going to see is the system capacity and the size. So that scaling from 1/4-inch to 1-inch uses the same differentiating core technologies regardless of scale. And some of our competitors, as you probably know, unfortunately use different equipment from scale to scale. They may see peristaltic pumps and reusable tubing at small scale, and then transition to a diaphragm pump and single use at larger scale. And this is not the way we want to maintain consistency across scales, and this is not how we do things at Repligen. So in addition to all the features we've talked about today, I wanted to call attention to the fact that we have a solid supply chain. Repligen really takes the supply chain very seriously. We design, engineer, and manufacture a lot of these components, and we do a lot of the work in-house. We also have more than 150,000 square foot facility expansion that's ongoing to further expand those capabilities and cater to the growing demands for the systems. So after this webinar, if you're ready to go out and purchase a system, we want to make sure we have the capacity to support you. So finally, I want to mention that Repligen offers multiple technologies as well that can create additional efficiencies in the chromatography unit operation in addition to this skid. In order to achieve the step change improvements required for today's purification applications, we've developed or acquired multiple new technologies to work in conjunction with our systems. The first of these is an affinity resin development platform that can generate custom affinity resins with first pass success in only 3 to 5 months. That's right, 3 to 5 months with first pass success. Next, we want to talk about the first and only sodium hydroxide stable catalog of affinity resins. They are now available. The first launches were for AAV2, AAV8, and AAV9, and there's more coming soon. But if you're interested in any of those 3, please let us know and we can pop a sample in the mail within the week. And then finally, the market-leading Opus columns. If you're not familiar with, you really need to look into these. We have columns that range from 50 microliters to 80 centimeters, and they allow that purification sweet time to be used for productive chromatography rather than column operations such as packing, qualifying, and unpacking. And I know I keep mentioning how much we love our operators. Having pre-packed column will definitely make your operators happy. So in closing, the Repligen chromatography system can deliver higher recovery with a more active product with simplicity. So I would like to thank you for your time and attention today. Hopefully you're just as excited about this chromatography system as I am. And I'd like to turn it back over to Lise so we can have some questions.
Hi again, and thank you so much, Julie, for the wonderful and inspiring presentation. And now we've got a few minutes for some Q&A with Julie herself. Welcome.
Thank you, Lise.
Let's start.
Hello to everybody out there.
Awesome. Let's start at the top of the list. I see some of you have been using the uploading function. And the first question is actually around the system column connection. Andy Davis asks, how do you ensure that the column inlet line is primed in such a way that the air doesn't get into the column?
That is a very good question. And of course, as we mentioned, all along the presentation, we have user experience in mind, and that's always at the forefront of how we design these systems. So we actually have a separate flow path that allows you to ensure that the column is primed. And of course, that comes with a predetermined recipe that will help you prime the column with minimal operator intervention. And that's something that, of course, either the field service team or my team as well can come and help train your operators as well, if it's not as intuitive as we think it is.
Exactly. Julie's own team, as well as others, are really there to provide as much consultancy as the customer needs around this topic, as well as others that might be application specific to them or specific to any other type of scenario that they're part of. There is another popular question, sticking with the disposable components. Don asks, are the flow kits made entirely of single-use components?
Yes, absolutely. All fluid contact parts are single use, and that includes the pre-calibrated sensors that we talked about during the presentation.
Exactly. And to make the operators' lives even simpler, right? All of those single-use components are already assembled together in the sub-kits for the flow path and arrive so that you can just plug it on the system and essentially be ready to run, right? Which
exactly. And as I mentioned, they come in 4 parts, and there's your SeptiQuick connections in between to make it really quick and easy, and also maintain that sterility throughout the flow kit.
Mm-hmm. And that's actually a good segue into a next question surrounding the flow kits. Are they available only with aseptic quick connectors on the inlets and outlets, or are there other options?
No, they definitely are available with other options. So for example, if a tri-clamp connection on the inlet and outlet is easier for you or allows you for better connection to your upstream and downstream steps, we can make that change for you. But anything internal to the systems, as I mentioned, are aseptic quick connections, so we maintain that sterility within the flow path.
Exactly. And again, sort of sticking with the theme of the flow path and guiding the flow path. And that there's a question around dead legs. What exactly is a dead leg, and why should we care about it?
So if you missed it in the presentation, dead legs really are caused by some of the older systems using hose barbs, and that hose barb technology requires that any valves that we place on the old systems have to be placed, sometimes a half inch or even an inch away from the actual main line. So the dead leg is caused from that piece of the hose barb between the main line and where the valve connects, or sometimes even other connections. So because we've completely removed all the hose barbs in the system, we've almost virtually removed those dead legs. And the reason why they're so important to remove is because that's places where your product could get caught up, where you might have additional turbulence, and where you're also potentially going to have some product that gets caught up that you have to require additional buffer. In addition to that, those dead legs cause increased volume in your entire flow path. And as we mentioned, dilution is a problem, and also time inside the flow path is a problem. So by removing those dead legs, you're removing turbulence, and you're also making a shorter flow path. So it's going to be a shorter time for your product to be inside the flow path as well.
Yes. And in your opinion, Julie, are there any modalities that should be particularly interested in that, or who could benefit the most out of those gains?
Oh, absolutely. So, of course, there's a lot of buzz in the industry right now about gene therapy. And although we, of course, always keep our monoclonal antibody and recombinant protein customers in mind, and this will work perfectly for them, some of the more sensitive biomolecules and viral vectors, such as Lenti, we really want to pay attention to those because they're sensitive. So the dead legs, the turbulence that we talked about, having a shorter flow path, that's really going to increase not only the efficiency, but it's going to reduce the chance that we're going to potentially have an effect on bioactivity of your Lenti or any other sensitive biomolecules.
Yes, and gene therapy isn't exactly working with a lot of product volume either, right? So any chance or any opportunity there is to avoid any of that sample potentially getting caught in those crevices or dead legs, that's also a very good thing for them.
Absolutely. And as we've removed those dead legs of virtually nothing, there's no chance of them being caught up in there as well.
Exactly. Continuing on that topic for a moment, what are some of the other benefits or some of the other aspects of the system that you would really highlight for, say, an AAV or a Lenti customer that could really benefit them in, going as fast as they are, working with as little product as they are, and an expensive product on that note also. So what's your
Right,
opinion?
of course. Yeah, so we hadn't talked about this yet, and we can provide more details specifically for anybody that's interested in all the different systems that we're talking about. But the quarter-inch system, for example, is really small, and that's something that you don't see with a lot of our competitors. We can operate with columns as low as 5 centimeter ID, and the flow rate there is between 16 mils per minute to 3 liters per minute. So having a really small ID column, having a low flow rate, and very, very small hold-up volume for that really small system is going to be key for our gene therapy customers, because they're most likely to be working with low batch sizes as well.
Mm-hmm. And then, once they wish to scale up, that has specifically been thought of as well to make that as smooth of a transition as possible, right?
Absolutely. So all of the system improvements that we've made are going to be maintained from the quarter-inch system, half-inch system, all the way up to the 1-inch system. So as you start to increase your batch size, you don't have to worry about the small size, the quarter-inch system, having different components or different features than the large-scale systems. And you'll see that with some of our competitors, where maybe the smaller scale system might use a peristaltic pump or something other than what they're using at the larger scale. With Repligen, all of our skids have the same components and the same benefits regardless of scale.
Exactly. And talking on this being a platform of technologies, a continuous platform, we discussed earlier that, we've really thought of the operators and a streamlined batch change process in cutting out some of those, excessive steps in that process. We talked about giving them pre-assembled subkits for the flow path, but we also mentioned sensors, right? We mentioned that you get pre-calibrated sensors. And on the sensor topic, Casey asked that, are the UV sensor wavelengths fixed or are they adjustable as well?
Oh, that's a great question. So you can modify anything with the UV. So we have pre-configured 254 to 280 for AAV and Lenti, and potentially 280 to 300 for MABs. But we also have a standard path length, which is 2.5 millimeters, but we can also offer 1, 10, and 20 millimeters as well.
Absolutely. And keeping in the theme of the platform of technologies, really responding to what the market is demanding, right? In addition to a process efficiency being a bit of a struggle for some of the newer modalities, lead times are also another kind of painful topic sometimes, right?
Yeah.
So what about the Repligen lead times for these systems?
I'm so glad you asked that question, because I was really excited about this as well. Currently, lead times of 6 to 8 weeks for the quarter-inch and the half-inch systems. That's almost unheard of in the industry. So we'll be able to get you your hardware in 6 to 8 weeks, and the first few consumable flow paths will also be available in those 8 weeks. And we aim to deliver our flow paths within 8 to 12 weeks. Of course, we want to focus on 8 if we can, but 12 is the max. So within 8 weeks, we could potentially get you up and running, and then you'll have your friendly field service engineer come on site and do the install, and then you'll be ready to roll.
Exactly. And the first 5 flow kits even come with the hardware at 8 weeks, right? And then if you want to order more, it's 12 weeks from then on. Exactly.
Correct.
And actually, we just got, yeah, exactly. And we just have a few minutes left. So to wrap up today, thank you so much, Julie, for joining us, for everyone engaging in the Q&A. And we truly hope that you'll join us for the 5th episode in Repligen's webinar series in 2022. Thank you so much.
You are very welcome, Lisa. It was my pleasure, and I look forward to hearing from anybody from the audience. And let us know if you have any more questions, and we will definitely follow up.
Absolutely. Thank you so much again for joining.
Everyone have a wonderful, wonderful day.